Morning guys. As a lot of you guys will know, light travels incredibly quickly and it's at a constant speed. It travels 186,282 miles in 1 second. This is sufficient where a flash of light could travel around the Earth 7.5 times in 1 second. Incredibly fast. LiDAR gun makers, laser gun makers, LTI invented it with American backup, use this constant obviously to calculate your velocity in your vehicle, in your car, your lorry or whatever. It was first pinned, the speed of light was first pinned down back in 1728 by an English physicist. Like a lot of English British inventors, he was a reverend with a lot of time on his hands, and he was a great astronomer, and he pinned it to within 1% of its true value. He put it down as 185,000 miles a second, so he was within 1% in 1728, which is pretty good going. So here we have a speed gun here. It's linked up to one of my pulse shifters, and a lot of you guys may know or may not know, but getting the jamming pulse in the right position is critical. It really has to be in the calculation time frame of the speed gun. Police always are trained to always use a speed gun at quite long range, at like 500, 800 yards or meters. This time frame, it takes the LiDAR gun pulse, like for instance, to travel a kilometre it takes 0.003 seconds, 3 milliseconds, which is tiny, but from that they can calculate your speed. Now on this dual track oscilloscope you'll see two pulses. One pulse is the higher amplitude pulse, which is fed to the laser eventually. On the lower track is actually the laser, is actually the input that you will get from a police speed gun. So I've got a police speed gun here, as you hear. This is a relatively old speed gun. It shoots a pulse out every 8 microseconds. That's 0.008 of a second, which calculates to 125 hertz. So I'll just give you a flash. As I say, the lower trace is the input, what would hit your number plate, and the other trace, the higher trace, is the jammer output. Here, I'll just give you an example, and I can manipulate this. I have found a way to manipulate these jamming pulses to wherever I want them, basically. I'll just give you a flash. As you see, the taller one is the jammer output and the shorter one is the input. Now it's not hooked up to the power source yet, but you can clearly see that these signals are not on top of one another. They are not the same, and they should be normally. If it was just fed straight from the photo sensor straight into the scope, these two traces would be on top of each other, because it's so instantaneous light. Obviously we're travelling like 186 miles in 1 second, but as you see, the shorter input pulse and the taller output pulse, the jamming pulse, are in a completely different position. You can actually measure this on any decent oscilloscope, even this quite old one, or an oscilloscope app, and you will see that the jamming pulse is a completely different position to the input pulse. Quite clever, huh? So, and as I say, I can manipulate this pulse. I can put it slightly earlier or later, these pulses, using my own method, my own discovered patented method. So as you see, bear in mind this jamming pulse has to be in the correct time frame. It has to be at the right sort of time, otherwise the speed gun could disregard it as interference. And all jammers basically are interpreted, or certainly on the earlier guns, were interpreted as interference. Although in the early jammers it came up E07, which was an early jam code in the very old guns. Only a very old barrage jammer, which a couple of guys called dumb jammers, a high frequency barrage jammer would set that off. None of this won't, and none of the current jammers will set off an E07. So there you go. So as you can clearly see, I call it a pulse shifter because it does really shift the pulse. So here we have the short input pulse, and in a completely different position, which I can calculate and work out, we have the taller jamming pulse. I also only use Osram 75 watt lasers. This isn't to give some fantastic paint burning output. This is so that I can get a reliable, tough laser diode, which is quite expensive, and I can give great coverage from one head. As we know, as I've discovered recently, most, if not all, modern jammers are actually using LEDs. Yes, I've got a few kicking around here, but you all know what an LED looks like. Yeah, power, you know, not badly powered, reliable, like 1.5 volt LEDs. That's what you're paying your $1,700, $3,000 for. They also use them in these auto brake systems, which all cars have now, these safety brake systems. I think Volvo introduced it, but all cars are fitting them now. And if you've got a dash radar laser detector, you will, like I, get frequent free laser detector tests, usually from the car behind, because the auto brake systems are mounted just by the vehicle's rear mirror, looking through the windscreen. And if they're behind you, you quite often pick up a lower frequency laser trace, similar to this gun actually, you know, 100, 150 hertz, because this is how it basically switches the brakes on in an emergency situation. So there we are, undeniable that the pulse shifter does in fact shift the input pulse to a jamming position. You can clearly see it there. So I'll call that a day, guys. Actually, historically, I mean, Galileo, a guy called Galileo, famous guy, in the 1670s, he actually worked out that light travelled at least 10 times faster than sound. So with the zilch technology he had in his day, he was doing quite well, really, I think. So there you go. So that's my pulse shifter in action, just on the bench, without a laser fitted, just onto the laser output. Okay, see you guys. Bye-bye.